Alright guys, let's go ahead and take a look at 5.4a. 5.4a focuses on prime and composite numbers. Knowing the difference between prime and composite numbers helps you understand how numbers are made and how they can be broken down. Alright, so uh, let's go ahead and take a look at it. Let's dive in. Alright guys, I wanted to start today by looking at an actual just star question. Again, I think it's better for me to show you the process to answer one of these questions because I think we know what prime numbers are. Prime numbers are just numbers that only have two factors. So, for example, you have something like 3. 3 can only you only can multiply 1 times 3 to get 3. There's no other combination, and no decimals don't count. So they have to be whole numbers. And because 3 only has two factors, makes it a prime number. Now, for example, 6, we can do 1 times 6. We can do 2 times 3. Okay? So all of these numbers, 1, 6, 2, and 3, are factors of 6. So just lining them in order from least to greatest. 1, 2, 3, and 6. 1 and 6 give you 6, and 2 and 3 give you 6. All right. So it's just important to know that a prime number is a number that only has two factors. If it has one more, it's automatically a composite number. So let's go ahead and look up here. Let's look at our question. It says Jalen was told to list prime numbers between 30 and 50. Okay, Jalen's list is shown. Okay, 31, 47, 41, and 47. Which prime number is missing from Jalen's list? All right, so they're asking you that there's one number that's missing within this list that's going from 30 to 50. Okay, now one of the ways that it's going to help you to really understand prime numbers and composite numbers is to know your multiplication facts. Because if you know your multiplication facts, you know, oh, well, I know that, for example, if I look at 33, well, I know that if I multiply 3 times 11, that gives me 33. So that makes 33 a composite number. So I know that 3 times 11 gives me 33, but also 1 times 33 gives me 33. See? So because I know my multiplication facts, I know that 33 cannot be a prime number. So I can go ahead and take that one off. Another thing is, like I said, if you really know your multiplication facts, so this one, you know, oh, 33, that's a multiple of 11. I already know that. What about 49? That is also another one that you can just see. Well, I know 49, if you multiply 1 times 49, but then also if you multiply 7 times 7, also gives you 49. So that makes 49 a composite number. Again, that's not it. So now we're between two numbers. Now we're between 39 and 43. And I want you to go ahead and take a pause here, and I want you to really look at those two numbers. Which one of those has only two factors? And I want you to just brainstorm a little bit and then come back. And I want you let's go ahead and take a look at it. All right, guys, we're back. So let's go ahead and look at 43 and then 39. I know this can get tricky, especially when you think, well, I know my multiplication facts, but then I don't know I know there's not a 43 in there, but I don't remember a 39. And then this is where it's really helpful sometimes to just guess and check, you know. And the way I looked at this is, well, I know 33 is a multiple of 11, right? If I go 11, 22, 33, okay. But what if I count by threes? I know that if I skip count by threes, 3, 6, 9, and eventually I'll get to 30, and then I'll get to 33, and then I know that 3 times 12 is 36. But hold on, what if I had another 3? That'd be 39. So let's see. 39 divided by 3. Let's see, 1 gives you a 0, and then bring down your 9. 9, how many times can 3 go into 9? That'll be 3 times. Ah, okay, so 9 times 3 is... Look at this, guys. So, we know that 39, we can get 39 multiplying 1 times 39, but then we can also get 39 by multiplying 3 times 13. This automatically makes that number. Let's go ahead and put those in least to greatest. 1, 3, 13, and 39. 1 times 39 gives me 39, but 3 times 13 gives me 39. That makes 39 a composite number. The only one that's left is 43. All right? Again, if we know our multiplication facts, finding prime numbers is going to be really, really easy. Let's go ahead and look at one more example. Alrighty, guys, we're back. Let's go ahead and take a look at this. So we have this new problem here, and this one says a list of numbers is shown: 51, 52, 53, 54, and 55. Okay? And it says how many numbers in the list are composite numbers. So now we're looking for composite numbers. All right, right off, again, because I know my multiplication facts, 55. I know 55. We can get 55 by multiplying 1 times 55, but then also 5 times 11. So that one's, sorry, let me go ahead and erase that real quick because we are looking for prime number, or composite numbers rather. So we have 1. We have 1 right there. We have 1 right there. So we know that 55 is counts. So I'm just going to go ahead and put 55 down. Oops, sorry. I'll go ahead and undo this. Then I'll do my right tool. Okay, there we go. 55 counts. Okay, let's see how many more we have. And here's another trick. So I'm going to go ahead and take this out just because I know I can kind of lower have less numbers to work with. Look at this. We have, anytime you have, look at the end of the number. Anytime you have a number like this, like 54 and 52, 2 and 4 are even numbers, right? So let me just go ahead and try. So 54, even numbers can be always divisible by 2, all right? Just remember that. Any number, and always look at the end of the number, okay? So it doesn't matter if the number has 10 digits or 20 digits. If the last number to the right is an even number, the whole number will be even. And so it's divisible by 2. So how many times can 2 go into 5? Well, we know it's 2 times because 4. And then get 4 and then bring down we get 1 and then we bring down our 4. That would be, how many times can 2 go into 14? That's 7. So that's 14, gives us 0. So we know that 54 is also a composite number, so I'll bring 4 down and I'll take it off my list. Again, 54, how do we get 54? Well, 1 times 54, but then also 2 times 27. 2 times 27 also gives us 54. Okay, that's why we took it off the list. And again, let's do that with 52. 52, because it is an even number, we will get a whole number. So let's go ahead. We won't have a remainder, which is what we're looking for. 1, and then bring down my 2. Then that's 6, 12. Oh, sorry. 12. That's 0. And then that's it. Okay, so now we know that 2 times 26 gives us 52, but then also 1 times 52 gives us 52. So that will also count. Okay, 52. Oh, sorry. Yeah, 52. So now we're in between 53 and 51. Okay, I'm going to go ahead and give you guys just a couple seconds to really look at it. And what strategy do you think would work to solve whether one of these numbers is prime or composite in this case? All right, guys, we're back. So I wanted to go ahead and take just a second to write my multiplication facts over here. I want you to look at it. So I'm looking and I'm thinking in my mind, I'm thinking, well, what multiples would give me 53? So I started listing multiples 7, 14, 21. I just started skip counting 21, 28, 35, 42, 49, 56. So see how I already went over? I know it's not going to work with 7. So go ahead and just take the 7 out. What about 8? 8, 16, 24, 32, 40, 48, 56. I went over again, so it's not going to be 8. And notice how the 53 is it doesn't have an even number at the end. I know that none of my even numbers would work. So I know that 4, 2, 4, 6, 8, none of these would work. Okay? So that kind of leaves me with 3 and 5, okay? And 5, you only, when you skip count by 5s, you only get 5, 10, 15. Look at the ones. It always is either a 5 or a 0, 5 or a 0. So 25 and then 25, 30. So notice how it's always, these numbers are very easy to know which, if it's a multiple of 5, right? I don't care if it's 95. Oh, I know that's a multiple of 5 because it has a 5 right there. So that's really easy to kind of just tell apart. So none of these, I mean, it's turning to be, in my mind, a composite number. But what about 51? So if we said, well, I know 51 isn't, it's not on my list over here for 7 and 8. I could do 9, but again, I know my multiples of 9, and I know that's not, 51 isn't a number. So let's go ahead and just try, and this is sometimes what you have to do. You have to just go in there, and then I'm going to try and divide 51 by 3. Because again, I'm looking at the 51. I'm looking at this number, and the number is a odd number, which, like, again, none of the even numbers are going to be a multiple of that. Okay, and I know 5's not going to be a multiple of that either because it doesn't have a 5 or a 0 in the ones. And 7 and 8 won't work because I've already listed them here and it's not one of the multiples. So let's go ahead and just, I'm kind of just picking one thing and then trying to see if that works. And if that didn't work, I'll go to the next thing. And all these little strategies that I have, like I said, listing the multiples, knowing whether a number is odd or even can really help out too. So let's go ahead and look at this. So 3 and 51. I know 3 goes into 5 one time. So that'll be 3 right here. And then that gives me 2. Ooh, look at this. Break down my 1. That's 21. I know 3 times 7 gives me 21. Look at that. So that means that to get 51, I can multiply 1 times 51, but then also multiply 3 times 17 to give me 51, which makes 51 a what? A composite number. So that means 51 also goes on my list. I'll take it off, and then it says how many numbers on the list are composite. 1, 2, 3, 4. 4 numbers are composite. That's my answer. All right, guys. I know this one seems a little bit kind of complicated. I know there's a lot of little things you have to do, but I promise, if you know your multiplication facts, this will definitely help. All right, guys. I'll see you in the next one.